The battery in your next car might be made from table salt. It's cheaper than lithium. It survives the cold. And China is already mass-producing it. But there's a catch. One tiny physical fact that changes everything, so I simulated it. Sodium versus lithium, ion by ion. Here's exactly what salt costs you and what it saves you. Every phone, every laptop, almost every electric car runs on lithium. Lithium is fantastic at storing energy, but it has problems. It's scarce, it's expensive, and most of it comes from just a handful of countries. Mining it takes enormous amounts of water and land, and in the cold, a lithium battery can lose a huge chunk of its range. So for years, the whole industry has been hunting for backup, something abundant, something cheap. The answer might be sitting in the ocean. Sodium, one row below lithium on the periodic table, its chemical cousin. There's a near limitless supply of it in seawater and ordinary salt, and because it sits right below lithium, it works almost the same way. A battery is just a device that shuttles ions back and forth between two electrodes. Sodium can play that same game. Watch. The ions leave one side, cross the electrolyte, and fill the other. It charges, it discharges, just like lithium. So why isn't everything already made of salt? Because of one number. A sodium ion is about 34% bigger than a lithium ion. 1.02 angstroms versus 0.76. That sounds tiny. It isn't. The standard anode in a lithium battery is graphite, layers of carbon that lithium slips neatly between. Sodium is too big to fit. It jams, so sodium batteries need a completely different anode. Hard carbon. And a bigger, heavier ion means you simply can't pack as much energy into the same space. That single fact, the size of the ion, cascades into everything else. Here's what it costs from the real simulation. This is a sodium cell and a lithium cell discharging side by side. The sodium cell runs at a lower voltage, about 3.5 volts on average versus 3.6 for lithium, and its energy density is lower. Today's sodium cells store roughly 140 watt-hours per kilogram. Good lithium cells store well over 200. In plain terms, for the same weight, a sodium battery takes you less far. That's the price of the bigger ion. But now the other side of the ledger. And this is why sodium is exploding right now. It's made from one of the most abundant elements on Earth. No lithium mining, no cobalt, no nickel. That makes it cheaper, and its supply can't be choked by a few countries. It handles the cold far better. Where a lithium battery sulks at -20 degrees, sodium keeps working. It's safer, more tolerant of abuse before it runs away. And you can even ship it at 0 volts. Completely safe, which lithium can't do. So sodium won't replace the lithium in your phone or in a long-range performance car. The energy density just isn't there yet, but it doesn't have to win everywhere. It only has to win where cheap and cold and safe matter more than range. Grid storage, giant batteries for the power network, cheap city cars, cold climates, backup power, and it's already happening. CATL, the world's biggest battery maker, is mass-producing sodium cells. The first sodium-powered cars are on the road. So is sodium a lithium killer? No, it's a lithium partner. The bigger ion is the whole story. It costs you range, but it buys you a battery made from salt. And for a huge slice of the world's energy needs, that's exactly the trade worth making. I ran every one of these numbers from real physics. Sodium and lithium simulated. If you want to see the batteries of the future,